Okay. Good. Hi. Hi. Okay. Hi. Good. So last week we were thinking of allocations. Okay. And remember, this is a description of who gets what. So for now, we have a fixed endowment. I will try to write bigger, but it's difficult. But I will try to write big. Fixed endowment of goods, of different goods, Wj, and an allocation is just a vector. A profile X is going to be X I X1 1, X1 2, sorry, X2 1, XL1. This is what one gets of each good. Yeah. X N1, XL NL. This is what Mr. N or Mrs. N gets, and this is for everybody. Yeah. And feasibility means what we give to people cannot be more than what we have. So the sum of the sum in I of X X J I is less than or equal to Wj. So in total, what we give to each person, summing up, cannot be more than what we have. And we started thinking about how are ways, how does society, what are ways, how does society choose allocations? And by choosing, I mean what kind of institutional arrangement, what kind of mechanisms does it use to choose a particular allocation so that a particular allocation appears? Markets, lotteries, priorities. Could be in some situations could be simply the stronger person. We didn't discuss that, but that's also possible. There are many possible ways in which society chooses these allocations. And what we are most interested in is how can we evaluate them or judge them? Okay, are they good? Are they bad? And for that, we derive three properties that are important, which were fairness, stability, and efficiency. There may be others, but these are three that make sense. Fairness, just roughly speaking, means what you think it means. It means that people consider, according to some criteria, these allocations are they give, for instance, equal chances, or people are in some sense equally satisfied with what they get as what they could have gotten, or something like that. There are various definitions. Stability refers to the idea that the allocation is final, so that there are no further possible arrangements that will lead to a different allocation. And the last one is efficiency. An allocation is efficient if there is no other one that is unanimously better, or said it differently, if the allocation is such that any improvement on this allocation for some individual necessarily means that somebody else is worse off. Okay, so we had these definitions, and we started thinking a little bit about certain of these mechanisms, yield allocations, whether those allocations are fair or not. Okay, so are fair or not, are stable or not, are efficient or not. Okay, is this clear? So in particular, the most, for us during this course, what we are going to refer most to is, of course, the notion of efficiency. And as I said, an allocation is efficient if there is no other allocation, X prime, such that it is unanimously preferred, meaning everybody agrees that X prime for them is better than X. Okay, so when you ask everybody and they would, you know, are you happy, are you at least as well off at X prime than at X, they all say yes. And somebody says, actually, not only I'm just as well off, I'm actually better. If both are just as good for everybody, then it doesn't really make a difference. Okay, so it must be that at least some person is better off. Okay. Alternatively, you can see of this definition saying that if for some individual X prime is better than X, right? So that means for some individual, what I gets in X prime is better than what she gets in X, it must be that for some other individual, J, it's not true, because otherwise everybody would unanimously prefer X prime. Okay, so that's the other alternative definition, is equivalent, is just to say, well, everybody agrees, or if some person likes X prime, there must be somebody who disagrees and doesn't like it. Okay, so that means if you improve somebody, necessarily somebody must be harmed. Clearly, the inefficient allocations, we can agree that they are bad because, look, there is something else that is better for everybody. I mean, we can discuss about whether this one is good. That doesn't mean efficient allocations need not be very good, but inefficient allocations, there is something clearly better for everybody. Okay, so they are bad. So it's kind of a negative concept in the sense that if you do not meet this criterion, you're clearly not very good. If you meet it, it still may be very bad, but at least you meet this criterion. Okay. For instance, we saw, remember, this is the plot that we had when we discussed the Yosemite, and we had the Q. And this line here represented the relation between waiting time and the probability of getting the good. And we had these two families. One of the family, the blue family, they actually preferred to choose this amount of wait. They would go very early to secure a high chance of getting in, while the red family, they would go later and they would have a lower chance of getting in. Okay, and this is because they have different relative willingness to wait for the ticket. And what you see in the plot is that for both of these families, the indifference curve associated with the lottery, what is the lottery? Well, their probability of winning is equally high, but they don't need to wait. You wait in the queue, but in the lottery, you don't wait. Well, the probability of waiting for both of them in the lottery, the utility they obtain from having this probability, which for the blue family is lower, but for the red family is higher. But for the blue family, although they have a lower probability, it still compensates the fact that they actually don't need to wait. So both families are on a higher indifference curve. What does it mean that both families are on a higher indifference curve? They both prefer it, right? So if they both prefer it, is the allocation that the lottery gives Pareto efficient? Yes? If you have something that both of them prefer, the initial allocation in which one of them gets this probability and this amount of weighting and the other one gets this probability and this amount of weighting, is the initial allocation Pareto efficient? No, because we found some other allocation, namely this one, that is feasible because we just have run a lottery and a lottery is feasible, and thus new allocation is beta. Okay? It's beta for both, and therefore the initial allocation is not Pareto efficient. Does it mean that the next that the lottery is Pareto efficient? What do you think? Does this mean, therefore, that the lottery is Pareto efficient, since it is better than the initial allocation, the lottery? Not necessarily. There may be yet another allocation that it is still better than the lottery. Okay? The lottery need not be Pareto efficient. There may be another allocation that is still better, that they both would prefer, right? And therefore, in that case, both of them, this new allocation would be also Pareto inefficient. But what we know is that it is Pareto superior to the original allocation. Okay, it's Pareto superior to the original allocation because both of them are better off. Is this clear? Yes. Yeah. Right. So suppose there was a family who really doesn't care about waiting, they just want the good. Then the queue for them, they can secure the queue to get in for sure, right? And they would never prefer a lottery in which their probability of winning is lower. So in that case, the comparison would not be indeed, you could not say that the lottery Pareto dominates because there would not be such a family. That's correct. Okay, so if there was there would be a family that would oppose this exchange. Okay, so this of course depends on the preferences. As long, in this case, I depicted the preferences in this way. If you had somebody who really doesn't care about waiting, by the way, how would the indifference curves look if you do not care about the time? They would be vertical lines, right? Because no matter what the horizontal lines, right? No matter what the time of waiting, your utility is the same. That's what it means that you actually do not care. It means that the indifference curves are horizontal because any point has the same utility regardless of the time of waiting if it has the same probability of winning. So that means that the indifference curves could be horizontal. And so you could see that as long as one family has horizontal preferences, their choice would always be up here, that is, come at the beginning and win for sure, and they would always prefer this point to this point. So you cannot make this argument. Okay? Any other questions? This is not the best plot to see Pareto efficiency. You will see later, we will see later a much easier way to think about it, but this is a way that you can see it in the simple two-dimensional graph that we studied already. Okay, now these concepts are somewhat connected, okay? So stability and efficiency are somewhat connected. Why is that? Well, suppose that people care only about what they get. Okay, they don't get about what others get. They don't care about what others get. They only care about what they get. Okay, this is happening. Makes sense for some cases. The Yosemite thing, I don't think you care about who goes if you don't go. Okay, but it may not be in other cases. Okay, can be. But for now, let's assume that you only care about what you get. Then stability and efficiency are very much connected. If something is efficient, it means that there is nothing else that you can improve everybody, right? And what stable says, you cannot find an arrangement in which at least some of the people exchange their goods to improve. Remember the example we had with the queuing in the Senate. You remember this example? In the queuing in the Senate, there was some benefit from exchanging that came from the fact that the people who are very poor value money more relative to time than people who are very busy like lobbyists. And so once the people with the time get the access, right, they exchange it for money. Do you see this? So now, suppose the allocation is Pareto efficient. If it is Pareto efficient, it means that nobody can improve without harming someone else. So when you make a deal and you are in a Pareto efficient allocation, both sides must benefit. In general, when you make a deal, you expect that if people are rational, nobody is harmed. None of these two people are harmed. Okay? So I make a deal with you, you agree, I agree. It must be that it is not bad for us. Because nobody else cares about us, what we get, what we exchange doesn't in any way affect you. Both of us are better off. So if we found such an arrangement, it means that the initial allocation was not efficient. Do you see this argument? Let me do it again, okay? Because it's a bit more complicated, but so we start with some allocation, X, okay? And in X, there are two people, for instance, A and B, or 1 and 2. I use 1 and 2. Let me use 1 and 2, okay? People, yeah? 1 and 2. And they decide to make, the allocation is not stable. So we say X is not stable because 1 and 2 would like to trade. Okay, they would like to, between themselves, change things. So 1 and X is not stable because you can find two people who are going to exchange things. Okay, for however they are going to exchange things, I don't know, maybe one pays the other to do something, or one pays the other to get something, or they exchange what they got. Okay, or in the case of apartments in Vienna, one who gets the apartment sublets somebody who doesn't get the apartment. For instance, that happens, right? So X is not stable because 1 and 2 would like to trade. So clearly, there is a resulting allocation X prime. X prime is the outcome when you 1 and 2 traded. Now, for 1 and 2, X prime is better than X because they traded. They exchange goods. So it must be better for them. They must have gotten something. One of them must have said, hey, that's great. I'm happier. And for everybody else, doesn't matter. Because they are not affected by the trade. Right? I just said whatever 1 and 2 get doesn't affect 3, 4, or 5. Now, this is not always the case, and in that case, stability is not so connected to efficiency, but in the case in which what you get is what matters to you, then stability is connected to efficiency. Think about it in the case of, in this university, to get space in courses, we use a system based on points, right? And you need to learn to navigate this system, right? It's important to learn to navigate the system of the points. Now, suppose you use some points and some other student uses the points. And at the end, you get some courses and the other student gets other courses. Right? And now suppose that you end up in this situation in which actually you prefer her courses and she prefers your courses. Can happen because chose the points different. Can happen. And then you exchange. You are allowed to exchange. Why would you exchange? Because both of you are happier, right? And everybody else, do they care? I mean, why? Yes, of course, they care, yes. Okay, you said so. That's not fair. Good. May not be fair. But does it benefit to you that it is Joe or Jim who takes your spot if you don't get the spot? Well, unless you are friends and you want to be in class with them or something like that, very minor, okay? This can always be false. But mostly, right, you don't care why you are in the waiting list. You just care you are in the waiting list. No? Mostly. I mean, you may care a little bit about who is that was ahead of you, but mostly you care that you are in the waiting list. So when you are asking between X prime and X, In both cases, you are in the waiting list. In this one, it's one who got your course, and in the other one is two. Does this make your life different? No, except for you feel outraged from the fact that somebody cheated on the system. Because the arrangement was that you had to use the points. Everybody agrees this? This is not something you like, right? No, if I were to allow this, you would be pissed. But not because of the allocation, but rather because of some concept of fairness, or generally that there is a lack of legitimacy of the problem. And that's why we care about the stability. We care about the stability because you would be pissed. Not precisely because you don't benefit, but it would be bad in this way, that the system is not being respected in some sense. Do you get this? Now, the example I just gave you, the allocation in which there is the exchange is Pareto efficient. So one of you guys would write me and would say, listen, it makes no sense to have this system. Everybody benefits. Right? The other day, I mean, because I am doing this job as SPL and I have to do this at the faculty level, I got a student who wants to register in a course for which we have space. And the course hasn't started because it's blocked in the second half of the semester. But because it's too late, the student cannot enroll. Okay? Would it be Pareto efficient that he enrolls? Yes. Nobody's harmed. He would be benefiting. Does it fail to fulfill the rules that all of you guys have to abide by? Yes. This is something that Yuan has to measure. So that's why we not only look at efficiency, we also look at stability and fairness, which sometimes captures this. Okay, but efficiency and stability are very connected, because if you have an efficient allocation, then you don't need to worry about stability. But if you don't have efficiency, then maybe on top of that, you don't have stability. Does this make sense? Okay, now, on the other hand, efficiency is not connected to fairness. Because any allocation in which one person receives everything by the fact that they are named in such a way, or that their identities, whatever, is Pareto efficient as long as people value to have more rather than less. Because how can you convince this person who has everything to agree to move to somewhere else? You can't. You can't. And really here, we need to give this person everything, okay? Not everything of one good or something like that, but actually everything. But if that is the case, this concept just says it's great. It's not great, as I said. It's just a negative definition. So this allocation is very bad, but it satisfies this criterion of efficiency. But now, and also stability. Nobody can convince this person to change. So this allocation is also stable, right? So that means efficiency is not directly connected to fairness, because you can have an allocation that is perfectly efficient, is efficient always, yet it's not fair under any criteria. Okay, no matter what is your definition of fairness, that's not fair. Is it clear? So, a particularly relevant allocation problem is that of determining which patient gets a kidney, okay? This is a problem that society has to get solved, right? Because we need people who have a sickness to get kidneys, kidney transplants, and we need to get them kidneys. We can use kidneys from deceased people, but those are rare because they need to be quite healthy, young. You know, the ideal victim is somebody who dies in a car accident or something like this. And also because kidneys, although they are very heterogeneous, and different patients may enjoy them differently. By enjoying, I mean that they respond well in their body or not. So there could be a kidney that is excellent kidney, but if I need it and they put it in me, it doesn't work. I just die actually. Okay, because it doesn't work. And of course, different patients are in different stages of need, because some of them are terminal and some of them still, they are doing okay with their lives. So in many countries, there is a nationwide priority list, and the next available kidney gets assigned to the first person in the list who is not incompatible. And if a friend or family member of the patient wants to donate, they can only donate it to the person whom, directly. I can donate to my brother, for instance, and that would work quite well. But my kidney, in those places, most places I cannot donate them broadly. Now, there are other situations. I read recently that in Iran, for instance, it's allowed to buy and sell kidneys, okay? That for some Western people, this is crazy, I don't know, but I mean, there it works very well. It's the only country in the world that doesn't have a waiting list. There is a price and this works, okay? But in many countries, this is so-called repugnant market. It's repulsive to think about buying, and that it matters how much you pay. That's something that people in some countries, definitely in the Western world, often are revolted about. So that market does not exist. And instead, we use other mechanisms. But what some people recognized is actually that it's not necessarily the fact that we don't use a market doesn't mean we cannot think a little bit about exchanges. But there are different types of exchanges. So here, for instance, in New England, they first implemented and then extended to other places, is a system to allow that patients exchange kidneys. Okay, if I have a kidney, in the sense that, a family member of mine has a kidney, which is not valuable to me, I could perhaps get that person to donate it to somebody else. And that person's relative could donate them to me. Okay? That's the general idea of the trade. You don't trade in exchange of money, because also in the US, even if they are generally more amenable to using money for things, they don't even think of using money for this, but they exchange some kidneys for other kidneys. Okay? Now, however, there is this thing called double coincidence. Okay, double coincidence is an important concept in economics, which it is the general idea that what I have, you are interested in, what you have is probably not very interesting to me. There is no generally double coincidence. Okay, so when I go to the supermarket, I'm interested in their milk, and that's great, but they are not interested in my economics lessons. So I cannot get them to give me the milk in exchange of a class. So what do I do? What do I do? I use money. I teach you class, get money, buy milk. That solves the double coincidence problem. It would be impossible for anybody to teach economics if they want to survive in an economy in which you wouldn't have money. Okay? So here there is still the double coincidence problem. There is a double coincidence problem because the kidney that I have, you may not want. So that I have, my brother may not want, and the kidney that somebody else has, they may not value my kidney either. But somebody else may. Okay? So instead of, because you cannot use money, what we are going to use is a cycle. We are going to try to find enough people so that my kidney can get to the person who needs it, and that person, and I can get a kidney in return that I value. Okay? So this is more or less how it works. Suppose you have these 5 people, and the circles represent patients, and the squares represent kidneys. And these lines, this network, if you want, represents who can use what. So the blue patient can get the green kidney, but cannot use any other kidney. In particular, cannot use their kidney. If you can use your kidney, you are out of the system. Then the red patient likes the blue kidney, the green patient likes the red kidney, and then the purple patient likes this blue kidney, and the blue person likes the green kidney. So how the system works, roughly speaking, Well, it uses a system called top trading cycles that first looks at what is the biggest cycle that you can find. And the biggest cycle that you can find is these three people at the top. Because the blue likes the green likes the red, and the red likes the blue. So it's a cycle, you see? You start from the top, you go to the bottom, you climb up to the top, it's a cycle. There is a definition, I don't want to, but it's obvious that it is a cycle. Whatever idea of a cycle is, that's it. I'm not going to define it mathematically, okay? But that's the biggest cycle, so you take that out. Those people exchange. So the blue person gets the green, the red person gets the blue, the green person takes the red. You see that they're all happy with this because they get their preferred kidneys. And then you are left with these two poor people. The purple actually likes this blue kidney, but the blue person doesn't value the kidney. Doesn't value the kidney. Actually, the purple kidney is not very useful for whatever reason. So what they typically would do is they would stay in the pool. They would stay in the pool. They cannot be matched now. Maybe in the future, some people come with whom we can match them. Okay, so the first three operations are done, and the next two they stay in the system. Notice that at least we managed to get three people kidneys, which otherwise we couldn't. Yeah, because none of these people has a kidney that is usable for them. Okay, is this clear? Yeah, you have a question? No, you cannot choose. This is a system allocates you. You cannot choose. It's not like a supermarket. Because they are not part of the biggest cycle. So the little blue, she has a kidney that is useful. But the green, the person who likes her kidney is actually doesn't own anything that is useful. So it's part of a small cycle. So you actually eliminate these two because they are part of a small cycle. So first you open the big cycle and then the small cycle. Questions? This can be done mathematically, yes. So this guy with a beard, he derived the mathematics of this and won the Nobel Prize. But I don't understand what you mean by probability function. So you basically, it's actually a pretty, it's not so easy to show the kinds of things I'm going to explain to you in general, but what is very easy is to find. You basically just need to find, indeed, as I said, start with a big problem with which a computer does this very fast, right? They just need to find the biggest cycle in the whole New England, right? So this is like 20 million people. So you have a lot of people, you find the biggest cycle, you match them, you take them out, and you look at the rest and you do it again. That's how you do it. I don't know if you can relate this to probabilities, but can be, I don't know. It's a clearing system. Yes, it's like when you do in some markets, they have this clearing system in which buyers and sellers get matched. But here there is no money to exchange. There is only one good, which is the kidney, but the kidneys are different. Yes. So the allocation rule is efficient. Let's see why it's efficient. Okay, and you have to get to this way of reasoning. Why is this efficient? Is everybody happy with this allocation rule I gave you? No, you already complained that these poor people at the bottom, they don't get anything. But could we make them better without harming the people at the top? How? This guy would already be like, what? Sorry. I got the Nobel Prize. They checked my proof. Somebody did. No, you cannot improve these guys because the only way is that these people could be better off is if he gets the green. But who would be harmed if he gets the green? No. If the only improvement you can do is for the light blue patient to get the green kidney. But if the light blue patient gets the green kidney, who is harmed? the dark blue patient. Okay, so you already find somebody who is not happy. Okay, everybody else gets a kidney they like, so clearly this is possible. And the purple one, I mean, you could, the only question here is whether you force the blue patient to give up her kidney, even if she doesn't get anything in return now and has to wait. Okay, but that's kind of a constraint that you put, that nobody has to give up kidneys when they don't get anything. So that's not feasible. Okay, because that would be like expropriation. You would need to take this kidney out of this person. This doesn't really work. So you actually, in this case, it's efficiency up to the fact that you cannot take people's kidneys. Okay, does this make sense? I know that this is a sensitive topic, but I mean, I think it's also a very important topic, so that's why I bring it. The allocation, of course, is not MB-free. Okay, it's not fair. And you already complain, because people complain more about fairness than anything else. It's not fair. Why? Because we already saw. For instance, it's not MB-free. Why is it not MB-free? I mean, it's not egalitarian, but the concept of egalitarian here would be a little bit meaningless, because every single kidney is different. So what does it mean egalitarian in a world in which everything we have is specific? It's difficult to say. Yeah? But what we could think is MB-free. Does anyone envy the kidney that someone else gets? Is it MB-free? No, why not? Yes? This light blue person is again envying what? The dark blue person. The dark blue person. Now, does it satisfy equal treatment of equals? Yes? No, it's not fair. Yeah, we already decided this. But there is a weaker property than equal treatment. Sorry, than there is a weaker it doesn't satisfy MB-freeness. But a weaker property than MB-freeness is equal treatment of equals. If two people are equal in every respect we care about, we want to treat them the same. Okay, that's weaker. We saw the other day. You can check your slides for that. But is it true here? No, why not? Okay, yes, so light blue is very similar to dark blue. What is the difference between light blue and dark blue? They both have a kidney, right? Yes, in the back? That's not true, yeah? So the light blue has a kidney that someone wants. Purple wants light blue's kidney. What is the problem of light blue is that the person who likes her kidney doesn't have anything that other people want. Is that a property of light blue? No. This is a property of the other people, in a sense. So this system doesn't treat equals equally. Of course, if you define equally by everything is exactly the same, then the definition is meaningless, because you will only have one person. And then it's, of course, true. I am treated like myself. But that's not a meaningful definition. You need to extend it a little bit here to people who have a kidney who is valuable. Purple, you could say, listen, it's fine. Nobody likes your kidney. Sorry. Okay, I could imagine you could say that it's not unfair that purple is treated different from green. Okay, but that light blue is treated different from blue, I think it's unfair both in MB-free and in my opinion, but this is opinable, is not. But in my opinion, it's also unfair in the sense of equal treatment of equals, because you must have these two people being similar. If not, then your definition of equals is too narrow. It's only one person would be like that. Okay. Questions on this? Yes. There is no silly question, yes? Well, the preferences are in the system, but they are just in the form of the scientific compatibility that the doctors can know much better than me. It doesn't make, what sense does it make that I have preferences before, I have no idea whose kidneys are good for me. The doctors know, right? So that's what they check, the blood and a few things. I have no idea. There are some, you can predict this quite well, right? The doctors can, but people, so it doesn't make sense to think about preferences of people other than what the doctors tell you. Now, you could say, oh, what you mean by this is that they like young people, they would like a very young kidney or something like that. That could be an issue, but I think most people, there are some requirements, and as long as they are met, none of these people is bringing a 92-year-old grandpa to give the kidney, and the kidney is already in very bad condition. There are some criteria, and within those criteria, it is you can choose not to be part of the system, yeah, but you also don't benefit from the system. So you can choose, yes? Because you have not your kidney, of course, but you have a family member or a friend who can give a kidney because you can live with one kidney reasonably well. Okay? It's not perfect life. I don't advise people to go out and give up one kidney. It's not a good thing, but it is, you can have a good life. That's why it's allowed medically, because the value of your second kidney is much lower than the value for a person of the first kidney. So that's why they allow this. Otherwise, it would be crazy. Yes? Yeah. Well, scientific or not, I would ask for a definition that you use, and I would ask you to apply that definition logically. I wouldn't ask you what is your opinion. If you start an answer which is, unless I specifically ask for your opinion, do not start the answer by, in my opinion, because that's not what I asked, okay? But it could be that sometimes I say, discuss or something like this, and then it's not that you have to really give me your opinion. I'm not interested in that, but I'm interested in some argument. And there you could give me your opinion, but it doesn't really matter to me if you believe it or not. Let me put it this way. It's just whether you can make an argument whether this is good or not for some reason. For instance, she didn't like the exchange of the students for fairness. You could say it's her opinion. What I care about is that you can translate this into the definitions that we discussed. Well, this is not stable and so on. Okay, and in my opinion, that's very bad. Well, that doesn't really, I don't care about that part. But you can, Okay, this buyer and seller is not so important. We already discussed it in the case of the auction. So I will skip it. But you have it there if you are interested. Basically, all that it says is that when you have really exchanges of goods for money, what you care about, as we discussed the other day, are that the people with the highest values get it. Okay, and the distribution of the money is not really very important. But that's not, not so important. I want to move to the second part of the lesson, in which we are going to focus on problems that we understand a little bit better than these general problems that we had so far, or these examples, and rather think about the general thinking in the space in which we have two different goods, okay, that we can exchange. And instead of having one person like before in the first lessons, we are going to have two people. Okay, we could have more people, but again, just like with two goods, two people will allow us to do some graphical representation. Okay, but nothing would be different if we had more people. Actually, you can think of this as not one person or two, but rather as a general thinking of groups, if you want, or you can even think of or types. For instance, one of the people could represent men and the other women, and so on. So what we had before was this cheese and beer for Anne. And remember, Ang has some preferences. These are the possible choices. And there is an allocation for Ang is X1A, X2A. This is what Ang consumes, and she values it like that. That's what we saw before. What is going to be new is we want to think a little bit together, Ang and Betty. Okay, we bring somebody else, Betty, and we want to see how they together interact, like we did before with the families and the probabilities. So the first thing we can depict in this graph is not only what Ang consumes, but how much cheese and how much beer we have. Okay, we can say, listen, we are interested in allocations that are feasible as a society. Notice that Anne doesn't care what's feasible. She would like to consume as much as possible. She doesn't know how much beer and how much cheese there is. But we as a society, we know this is how much cheese there is. That's how much beer there is. You can't consume any more than that because we don't have it. So for you to consume that, the rest of us, we have to consume nothing. Yeah? The other person in this economy is Betty. So say that Anne consumes this amount. What is left from what she consumes, is what the other person consumes. Because there are only two, if we have 3 apples and I consume 1, I can tell you that the other person consumes 2. How do we measure this? Well, if this is X1A and this is W1, the difference between these 2 points, the red arrow, that's the amount of good one that B consumes. Whatever, in this case is Bob or Betty, doesn't matter, it's a B. Whatever B consumes is what Anne doesn't have. And so the red amount is the amount of cheese that Bob consumes, and the green amount is the amount of beer that Bob consumes. Why? Because we have a certain amount. Whatever one consumes, the other cannot. Whatever one has left, whenever one doesn't consume, the other will consume. So in this square, in a sense, we can depict with this single point, we can depict 2 allocations, or a full allocation, more precisely, 2 bundles. This is the bundle for Ang, and this distance and that distance up there measure the bundle for Bob. Okay, the bundle for Bob is computed as the distance between that corner from the box and this point, and that corner from the box and that point. Because it's just the remaining from what Anne consumes. And this way we can depict with 1 point the whole allocation in this economy, because we have only 2 people. If we had more people, we couldn't do this. But with 2 people, with 1 point, we can depict the full allocation. So an allocation is just a point in this box. The name of the box, because of the gentleman there, is called Edgeworth box, okay? And this is how people represent allocations in general when you have a 2x2 economy, 2 goods, 2 people. For instance, you could have capitalists and workers. That's something that for which people use the Edgeworth box. Borrowers and lenders, okay? That's something that people use the Edgeworth box. Men and women in the household. People use the Edgeworth box. You have like 2 groups, and they distribute things between themselves. And that distribution is what you study in this type of boxes. In this class, we are going to study very simple problems, okay? But this can be used in a quite general way to study problems involving this kind of 2 representative groups. And this is used quite often. Is this clear? So this is, you need to learn how to repeat, but it's very intuitive. You start with 1 person, you close the box with the amounts of the goods that we own, and then you compute the distance from the top, okay, from that corner. This is the point in which, of course, if you are in this point, Anne consumes everything that we own, so Bob consumes 0. Sometimes this is called the 0 of Bob. Okay, that is called the 0 of Bob, because if we are in this point, Anne has everything and Bob has nothing. Okay? And Bob, of course, doesn't like this very much, does he? He is not very happy here, but he actually prefers allocations in which he gets more, so they are southwest, while Anne prefers allocations that are, she has more, that those go northeast. So Anne likes northeast, Bob likes southwest. Okay, Bob likes southwest. This point, of course, is this point Pareto efficient? Why? There is no way to give something to Ang without to Bob without taking from Ang. So Ang would not be happy. There is no unanimous understanding. Okay, so this is important. This point is typically Pareto efficient, just like this point. These 2 points are, of course, not fair, but you know, life is not fair. So that's also a point. Yeah, so we can think of a particular bundle like this one here. This is the egalitarian, for instance. This is an important bundle in the box. This is the bundle in which each of them consumes W1 over 2 and W of good 1 and W2 over 2 of good 2. So for instance, if we have a kilo of cheese, each of them eats half. And if we have a beer or a liter of beer, each of them drinks half a beer. Okay, this is an egalitarian allocation. Nobody can complain for fairness, right? They are all treated the same. So it would be difficult to complain about the fairness. And these are their preferences. So this is the indifference curve of Bob. The red one is the Bob, and the blue line is the indifference curve of Ang. Bob improves if we were to move northeast, and Ang improves southwest. Okay? Is this clear? So how do you look at this allocation? Again, this is the bundle for Ang, the remaining is the bundle for Bob, but because Ang has a half of everything, Bob must have a half of everything. So that's how you get the allocation. Any questions? So this is the egalitarian allocation. Is this allocation Pareto efficient? What do you think? This is more difficult. Yes, no? How would we think of an allocation is Pareto efficient? What test did I told you to use? What do you have to ask yourselves? Is there something else where I can improve somebody without harming the other, right? That's a way to think about it. Is there something else that both unanimously would prefer? So who do you want to try to improve? It doesn't matter really. So let's try to improve one of them. Who do you want to improve? Ang. So let's improve Ang. So Ang has to move to an indifference curve that lies to the northeast, right? So it has to be that she lies on an indifference curve that is higher. But Bob cannot be harmed. Cannot be harmed. What does it mean that Bob doesn't get harmed? Yes, in the back? Sorry. More in the back. That she stays in the same indifference curve, right? If Bob stays on the same indifference curve, Bob won't complain. Is that right? Bob won't complain as long as we keep him here. Actually, we could make him even happier maybe, but at the very least, we need to convince Bob, okay? This is like, you know, when you have to vote something, I mean, you probably don't get, but, you know, when you are in a organization like this one where many things are decided by voting, you need to sometimes convince somebody, okay? So you really try to make him just worth their while, but you don't give them extra. You know, we want to get this approved. What would you want so that this gets approved? This. Okay, let me just give you that, okay? So that's what we do with Bob. He asks us to keep him on the red point, but we want to find a point on the blue that is better for Ang, that is on the northeast of Ang. So what about a point like, for instance, this one? Is that point better for Ang? Yes, it lies on the northeast of this. It's as if we gave extra amount to Ang. So we move from this point to this point. Bob is not better off. He's just as happy, but Ang is clearly better off. Okay, so this point would be a Pareto improvement. Like for instance, X prime is an example, which is better for Ang. Okay, because it's on a higher indifference curve. Okay. In fact, any allocation on this area is better for both of them. Okay, it's better for both of them. So the egalitarian allocation is not Pareto efficient. I already told you before that there doesn't need to be much relation between efficiency and fairness. I said there are allocations that are efficient and they are not fair, and this shows that there are allocations that are fair and they are not efficient. Okay, for instance, the egalitarian allocation here. Why? Because they have different preferences. They have different preferences and they can find a mutual beneficial improvement by giving up the egalitarian allocation and finding some other allocation that is no longer egalitarian. And you could argue that, you know, in some sense, Anne gets more than Bob. In some sense, I'm not going to discuss much, but they actually both prefer to the egalitarian. Yeah? At least Bob in weekly, so he's indifferent. Good. So what about X prime? Sorry. So we can find. Let me just follow the slides. I don't want to. If we ask which is the allocation that makes Anne happiest, given that Bob is not unhappier. So we can ask this question. Right? We can ask among all allocations in which Bob is not harmed relative to X, which is the one that Anne is happiest? Okay, and it must have this shape. It must be that Anne's indifference curve is tangent, sort of, to Bob's indifference curve at that point. It must be that they are really almost not touching, so that, you know, you can, if they were crossing twice, you can always find an improvement in between. Like at X, right? At X prime, you can continue to improve on this area. But it's only when they are both sort of tangent to each other, which roughly means that each of them is tangent to the same line. There is a straight line that goes in between the two. That's what the real definition is. There is a straight line that goes in between the two curves. Only when that is true did we make Anne as happy as possible without harming Betty. Okay? And if that is true, if we made Anne as happy as possible without harming Bob, not Betty, Bob, then it must be that this allocation is Pareto efficient. Because to further improve Anne, we now have to give up on Bob. To further improve Anne, we need to give up on Bob because any further improvement for Anne no longer touches on the red line. Do you see this? To keep improving Anne, we can't do it. So this point here where they almost don't touch anymore, where they are tangent, is a Pareto improvement. Yes? We already knew that X was not Pareto efficient, right? X double prime dominates X. What I'm arguing now is that X double prime is Pareto efficient. The one and only for Bob in this indifference curve. Yes. If we keep Bob just happy with what he got, the point that that we can make Anne as happy as possible is X double prime. It's a single point in this case, but need not be in general. Is this clear? So now we found a point that is Pareto efficient, and it has this nice feature that there is this tangency. And in economics, whenever you see tangency, it looks good. Okay? And it looks good because, roughly speaking, when there is a tangency, every point that is better for one, every point that is better for Anne lies up. Every point that is better for Bob lies down. That's great. Because that means this point must be best. Okay? Because if you could improve Anne, you would need to move up, but that necessarily means Bob is harmed. And if you could improve Bob, you need to go down, but that necessarily means you are harming Anne. So X prime has to necessarily be efficient. Clear? And graphically, when two curves are tangent, what you have is that there is actually a line that crosses through in between, if you want. That you know, both curves are tangent to the same line. More specifically, okay, both curves are tangent to the same line. And what is the derivative of the indifference curve? The marginal rate of substitution. And if both curves are tangent to the same line, what must be true? That they have the same marginal rate of substitution, because the slope is the same for both, namely, they both have the same marginal rate of substitution. So, relatively speaking, in this point xw prime, both Anne and Betty, Anne and Bob, okay, value the goods relatively the same, in the sense that the marginal utility of good 1 relative to good 2 is the same for both. Okay, the marginal utility of good 1 relative to good 2 doesn't mean that they like the same in absolute value. It could be that a marginal utility of good 1 is 7, and marginal utility of good 2 is 1. And for Bob, the marginal utility of good 1 is 14, but the marginal utility of good 2 is 2. So the ratio is the same, namely 7. Okay? So it doesn't mean that they value the goods equally in some sense, but that they value equally relative to each other. Okay? They agree on how they perceive the goods. And of course, that makes total sense. And that was not true before. Let's go back to before. At the point x, what happens here? Anne has some marginal rate of substitution that is how? How is the marginal rate of substitution of Anne relative to Bob at x? How is the slope? Is it very steep or very flat? Flat. Anne's marginal rate of substitution is flat. So in absolute value, the marginal rate of substitution is low. What does it mean that the marginal rate of substitution is low? It means that the marginal utility of good 1 relative to good 2 for Anne is lower than for Bob. Namely, relatively speaking, Anne likes good 1. Relatively speaking, I like good 2. Relatively speaking, Bob likes good 1. Bob would want to have more of good 1. Okay? Relative to Anne. They disagree in a sense. They find some mutual benefit in the exchange because they do not see the goods in the same way. If you ask Anne, she says, oh, I really would like a bit more of good 2. And Bob says, oh, I really would like a bit more of good 1. So how do we find an improvement? Precisely by moving in this direction, in which Anne gets more of good 2 and Bob gets more of good 1. And we keep in this way, we keep going from x to x prime and from x prime to x double prime, which is the point at which they perceive it equally. Because once they perceive it equally, there is no mutual benefit. This is the general understanding that you should have always in economics. Trade comes from differences in the way that you perceive goods. Countries, companies, individuals exchange, value exchanges only if there is disagreement in the sense of they perceive goods to have a different value. You know, for many, many years, the kind of exchanges that existed, think about the Silk Road or something like that. You know, the Asians brought, China, they produced silk that was extremely valuable in Europe. And the Chinese wanted other things, in particular, if possible, silver, but most of the time, not so valuable things that Europeans did. And they sent them back, and they benefited from the differences in the valuation of the goods. Because silk was abundant in China relative to the other goods, right? The Chinese brought a silk. The Europeans had silver, but didn't have silk. They sent silver. So they value the good they didn't have, and that's where exchange came in. Two countries that were exactly the same would never exchange because they would perceive the goods in the same way. Okay? So the same is true for people. The reason why we can find a mutual beneficial exchange is because they disagree on what they want. But that we already knew. This is what I told you happened with our two students who exchanged their courses. Why could they exchange the courses? Because the courses that one got was what the other one wanted. So this is just a mathematical or graph, in this case geometrical, but you can do it mathematical, demonstration of this fact. You can find an improvement when there is a disagreement. And yeah? Yeah, you can move, you will see, you can move whoever you want. I'm asking here a simpler question. So you will see, roughly speaking, okay, there are gonna be many efficient points. Some of these efficient points, like this one, are gonna be very good for Bob. Some of these efficient points, like that one, are gonna be very good for Ang. And here I just ask a very specific question, which is, how can I improve Ang without harming Bob? Because that's the one that comes from the definition of efficiency. I can improve somebody without harming the other. But I can also look at the allocations in which both improve, which lie somewhere in between, or in which only Bob improves, which will be on the same indifference curve for Ang, but on a tangent curve for Bob. Okay, I can find all sorts of efficient allocations, but we are looking at this one now. Any other questions? Yes? This is what they said. And this is the answer you were looking for, okay? So the contract curve is the curve, that doesn't need to be a curve, strictly speaking, but it's a curve, it's a mathematically a locus, it's a area, but it turns out in most examples we do is a curve. That contains all allocations that are efficient. In the sense that you can't improve one person without harming the other. And the one we found out is efficient. The ones we knew already, the corner ones, are also efficient. And I just depict here some representation. There are others. Okay, there are others. For instance, this one is a point in which Ang is just as happy as in the original point, but Bob is better off. Okay, and there are many points in between, and also there are points that Bob is worse off, but Ang is better off, and you cannot compare those. Any 2 points that are Pareto efficient are not comparable. By definition, one of them will be on a lower indifference curve, and the other one will be on a higher indifference curve. So you cannot really compare them in terms of efficiency, but you can compare them in terms of fairness, for instance, or something else. Okay, so this is called the contract curve, are the points that are Pareto efficient. That's just the definition. And in this graphical representation, it crosses through the 2 extreme points, but it also contains these 2 points that we already identified because of the tangency condition. Okay? More specifically, the contract curve refers to points that are in the interior, so that both of them consume both goods. Okay? Both of them consume both goods. There are also these so-called corner ones in which one of them consumes one good, but not the other. Okay? Because this can happen in a so-called boundary allocation. In a boundary allocation like X, what happens here? Let's think a bit about from the graph, okay? This is a good way of trying to develop some intuition that comes from the arguments of marginal rate of substitution. What happens at X? The allocation is in the boundary. So one of the person doesn't eat something. Who doesn't eat something? Ang. Well, Ang consumes all this amount of cheese and all that amount of beer. Who doesn't consume something? Bob. What doesn't he consume? Beer. His allocation, Ang consumes all the beer. You see? So Bob has no beer. Okay, it could be that Bob doesn't drink. This could be, but it's not the case because he has some preferences, Bob. He values both goods. Okay, it's not horizontal. He values both goods. And Ang has some indifference curve, which is this one, and Bob has that indifference curve right there. And I'm saying the allocation is efficient. Are the indifference curve tangent at X? Are they tangent? Do they have the same slope? Do you think they have the same slope? No, they shouldn't. I mean, I depicted it myself, so, you know, it's up to my lack of skills, but you see the slope of Bob is much flatter than the slope of Ang. Okay, Ang has a straight line, so the slope is just the red line, and you see that the blue line crosses the red line. It's not that the blue line, you know, would have to go up here. It could cross. So the blue line is not tangent. So who likes better relatively, who likes beer better relatively? Ang, why? How do we see this graphically? Anybody? It's a bigger slope, right? Bigger slope means, so Ang, so this is Ang's marginal rate of substitution. This is Bob. So, right? So Ang has a lower slope, right? Has to be lower because beer is good too. So when the slope is low, means that the denominator is big. Why is the denominator big? Well, means Bob, this Ang, likes good 2 more than good 1. What is good 2? Beer. So relatively speaking, Ang, the blue person, has an indifference curve that is flatter than Bob at X. So how would a profitable exchange look like? What would they want to do to improve both of them? If Ang likes beer better relative to Bob. Yeah? They would like to exchange so that Ang gets even more beer because he likes it better than Bob relatively. The slope of Ang is flatter than the slope of Bob, and therefore relative to Bob, Ang would like to get beer and Bob would like to get cheese. But what happens? Ang has the maximum. More importantly, Bob has nothing to sell. Okay, Bob would like to keep selling beer, but he has none. So there is no improvement inside the box. There is no allocation inside the box that it is strictly better, is weakly better for both than X, because the only allocations that would be better for both than X are allocations in which Bob gives more beer away, but he doesn't have it. That's why you can have a so-called boundary allocations to be efficient, because at that allocation, the person who consumes nothing of a good would like to keep selling it, and the other person would like to keep buying it, improve both of them, but we don't have enough. Okay, we're in the limit of the box. The person who has nothing cannot continue selling, so we settle for the best that we have, which is that Bob consumes nothing of beer. We cannot make him consume negative amounts. Okay. So this is the reason why you can have corner allocations. It can happen that even when a person doesn't have anything left, she still prefers to give it up, whatever she could have. Okay, and those lead to a corner allocation. Again, these are, as always in this course, corner allocations are not so important, but you need to understand them to understand the concept. Okay, we have a corner, a general tangency. So think about it in the negative way. Why do we have here the tangency? Because we started at X and we can move to X double prime because Bob has some beer to give up and Ang has some cheese to give up. If the box ended here, we couldn't move to X double prime and X would be efficient. But because we have some amount to give, we can move from X to X double prime. Okay? Questions? Okay, yeah. So on Thursday, we'll just like we did with choices of an individual, we first solved it with a diagram and then we understood it mathematically. We are going to do the same on Thursday, okay, to start the class. I'm not going to do it now because you're probably mentally fried, so this wouldn't help anybody. If you have questions or something, we can look at it again on Thursday. We are also going to do some examples, okay? You don't have questions.